Just before we get into the meat of the talk, I'm just going to share a little story with you so that we can so I'll put a little bit of context around some of the things that I'm going to talk about. So think about every time you come to, and I've been a .NET developer for over 10 years. Every time we came to deploying our applications, we would have this sort of feeling where we're not sure what's going to happen when we come to deploy, because we have like a manual process. So somebody's going to publish a website, copy some files over to a server. Did you remember to copy the right files? Did you update the correct config files? Very manual task. And so it would always be, everybody's on edge, get ready, we're going to do a deployment. It's a really big thing. And then we began to automate some of our processes. And then you get to, before we came to automating some of our processes, when you come to opening a Visual Studio solution and having a look at your project, is it really clear and obvious how you actually deploy your application? Because usually a solution is full of console applications, websites, maybe some helper applications. You don't know what the actual project is that you actually want to make live. So you've got to figure out what is actually the thing that you deploy. Moving over to automation, then you hand over to tools like, you might be using Octopus Deploy, or there's lots of other tools to deploy your application. You kick off a build, and then you're just at the mercy of the log file, just watching the logs, hoping that everything works and that it's all deployed, and you'll get a big green tick at the end of it. And you hope that it doesn't go wrong. And we have this, we have this constant battle between dev and ops, where, yes, I've done my bit, and something must be wrong in in the actual environment. So, and I'm sure everybody's been here, where they've said, yeah, it works on my machine. This is I used to manage a team, and used to have like little badges, for things like this every time I heard, a team member say this to me. So, we're going to talk about deploying .NET applications using new container technology. It's quite a big shift in terms of how we've deployed our .NET applications up to date, but it's more of a sort of catching up with how people within other developer communities are deploying their applications. Now, containers within the .NET world or within Microsoft technologies have been around for the past couple of years, starting to mature now over the last year and really settle down. So what we're going to do is we're going to have a look at a really brief look at what containers are. I would guess that everybody kind of knows what a container is if you've come to this type of event. But we'll have a quick recap. Usually, if I'm doing this talk to a complete .NET developer audience, then we go into a lot more detail, because some of these concepts are new. We'll have a look at how the containers actually work under the hood in Windows Server 2016, and the kind of tooling that you'll use in developing your applications, debugging, and deploying. We're not going to look too much on the orchestration and those side of things, although we will mention it, and you heard some of it in the previous talk. But I'll just kind of give a few clues and pointers in terms of where you can have a look. And we'll have some demos, so hopefully they'll all work. So a little bit about myself. I've been a .NET developer for the last 10 years, right from .NET 1.0, which quickly became 1.1. But I'm really, really, really passionate about archery, and I'm really obsessed about it. So if anybody wants to actually talk about archery after this session, I'd be very, very happy to do so. Recently, I was just telling some of the organizers that recently we just came for a family holiday, and we went to Afyon. We went to have a little horse riding and did a little bit of horseback archery. But I've just started to get into horseback archery now. So I'm here in Turkey. I'm really happy to be here for this trip. I've come all the way from England because I'm also happy to be here because of I get to catch up with some of the people who are doing this sort of thing here, and it's really alive and well here within Turkey. and it's a bit of a family affair as well, so my children really also do love Archby as well. Anyhow, so let's have a look at, so if we just wind the clock back a little bit and think about virtualization and where we kind of began. So we had a load of physical hardware which wasn't doing a lot. You know, you might have an operating system installed on there, one application, maybe two, maybe a bunch of applications sharing, you know, typically like an IIS web server, or sharing resources. We kind of quickly learned that we can make better use of that physical machine and turn and virtualize our operating systems. So the hardware was virtualized to the operating system, and then we could run multiple operating systems on the same bit of kit, getting a bit more efficiency out of that same piece of hardware. Containers is the evolution of that, is the next step of virtualization. So now we are now virtualizing our operating system and packaging our application up and presenting that operating system to that package. So this really now takes that approach of being even more efficient with our hardware, with our resources a little bit further. Although now hardware is cheaper and things, and you know, we don't really take those considerations into too much. We don't take that into too much consideration, but the containerization of applications is the next logical step of that. So with this, we can also achieve what we call like a higher density. So we can cram more applications on the same bit of physical hardware or the same operating system. And containers, if we look at the analogy, really kind of makes sense when you think about how goods were shipped across the world. Shipping of goods was transformed with containers, because if you can imagine, I don't know, if we had to transport all of the chairs and tables in this room and we had to take it by sea, for example, to be able to secure all of this furniture will be quite difficult, because the chairs and the tables are different shapes and sizes. But with a container, you forget about all of that. You load everything into your container. You have the infrastructure necessary to manage those containers, so you know the shape and size of the container, so you can build docks around how to lift the containers off the ships, place them back, place them into the docking yard. And so you begin to not really care what's actually inside the container, because if it fits inside the container, then we're ready to ship that. So I'm not cruel to animals or anything like that. It's just I thought it was a little bit funny, but it kind of drills home the point that whatever we can put inside the container, now we know when we have like a common language, a common interface in terms of being able to manage those things. So along comes Docker, and Docker is this set of tooling now that we use to manage our containers on a sort of a local level, and now higher up as well. Came about because this company, .cloud, was managing their own infrastructure and created this tooling, all open source, and it really kind of gathered some momentum. Now, I come at this Docker tooling and all of that because of the fact that Microsoft are now bringing container technology into the Microsoft server world. So I'm a complete newbie to containers, been using them for the last sort of year or two. And so this is a whole new kind of like a way of working for me as a .NET developer, like an enterprise .NET developer. But what it's done is it's created this common language where ops and developers can speak this common language, where we can package our applications inside of this container, and ops and developers now can speak in the language of Docker run, Docker start, stop, and so on. So we've got this like kind of common language now between these two teams. It works by hosting this Docker engine, which sits on your container host. And the Docker engine is the thing that then spins up your containers, starts and stops and manages them and reports back on how they're actually doing. Now, within the Linux world, some of the features built into the operating system that allowed this kind of technology to develop, things like process isolation, sandboxing file systems using control groups. These things are really alien to the Windows Server world. There's nothing like this that was in the Windows Server world. So these types of concepts have been brought over to Windows Server, and really the Microsoft Windows Server team had to really go and strip out a lot of the code and really get into the guts of how Windows Server operates. On top of the Docker engine, there's a few other bits and pieces. So the Docker engine is the runtime component. We then build these things called container images, which are essentially like a package of our application. The Docker image is made up of layers, and you can think of the layers as zipped files all built on top of each other's, where we begin with a base layer, which will be like a vanilla operating system. So if you install if you install Windows Server out of the box, that will be your base layer. And then on top of that, you will add your application and other concerns on top of that, building them up as each as individual layers. The individual layers can be shared. So if I have two containers, two applications using the same stack, so using the same base images, then those base images, Docker is clever enough to share that between the two images. Those images are going to be housed somewhere. So once we build an image, so we then have a repository of images, and you can think of this like almost like the way that we use source control. So we have a central Git repository where we might push our code changes to and pull them from. Well, Docker has a registry that you can push and pull container images to. You can also host a private registry, so that the private registry, you can control who has access to that, because you might be building your own application and you don't want to host them publicly, like on the in a publicly available Docker registry. Docker had a relationship with Microsoft going back before the containers work commenced within Windows Server, and that was within Azure, Microsoft Azure. You had the ability to create Linux hosts and to manage Docker containers there. So there it was just like any other cloud provider like AWS and so on, and so they already were working with each other. But let's have a look at some of the good stuff here. So this is a Docker file. If you've not seen this before, I hope everybody can read it. It's a file that describes how your application is built. So we begin with our base layer, as I have. We begin with our base layer, which is described normally using this from keyword, and this here tells us that this is an image, which is an ASP.NET image. It's got a version number 4.62. This matches the .NET framework that's supported on that base image. And then on top of that, we're now going to start to build our application. So from a local directory, I copy a bunch of files into this container. I'm exposing this port. And then you might be familiar with some of these commands, or may not be, because this is how you manage IIS through PowerShell commands. So I begin by removing, so I have a base Windows Server image here that has IIS installed. And what I do is I remove the default website, I create a new website, all within creating this container, and then define what happens when the container is started. So we have this thing called the entry point. This is a very basic web app. What I've done in this scenario is I think it might actually be a .NET 3.5 application, a web application that I've deployed and built into as a container. Here's an example of a console application. So here what I've done is, the only difference here is we have a different base image, you might have noticed here. So this time, this base image, now this base image and the previous one, these are base images that Microsoft has actually released themselves into the Docker Hub. So if you go to hub.docker.com, I think it is the URL, you'll find these base images. They're free. You can use them in the creation of your own images. So the .NET Framework one doesn't have IIS installed. So it's a Windows Server image. It doesn't have IIS installed, it just has the .NET Framework installed on there. And the particular version is 4.62. You can go back and get the 3.5. I don't think you can get anything older than that. And here, after a bit of metadata that I've added here a console, an exe, that I've added to this container. So this add command pulls the exe into the container, packages it up, and then describes now this entry point. When this container starts, this console application needs to be fired up. So what we'll do is we'll switch over to my demo and have a look at how this works. So what I will do is I'll first show you Visual Studio. And so for the first application the first Docker file that I showed you, this is the web application that I used. So this is a standard, if I do a right click, add new project, just a standard MVC application. To that, I added this Docker file, and I've also added something called the Docker ignore file. So a bit like a git ignore file or a TF ignore file if you use that as source control. It just tells Docker when you're packaging up this application to ignore certain files. So that's my Docker file. I've then gone and published this website to a local directory just using a publish command. Now these steps that I'm showing you is a very manual way of doing this. What you really want to do is you want to automate this. So this would be the responsibility for doing all of this would be your CI server, your build server will do these type of things. So we publish, and all I'm doing is I'm writing to a local directory. So I've published my website to a local directory. And from there, I have a bunch of commands, which I'm just going to just bring up. Once this readme loads, I'll tell you what, it'll be easier to show it over here. So I have some commands here to build my Docker container. So first I start with this command here, the Docker build command. Okay, so this Docker build command says, okay, look in this directory, look for a Docker file, and then build the container using that Docker command, using that Docker file. I've given it a name, just for argument's sake, I've called it demo2. And so I've called it, done a Docker build, and then I can run a command here now. So if I run this command, Docker images, we will see listed here the web applications now that are available, the list of images that are available for you to now create containers for. So the images are your packaged up application, and Docker images will demonstrate that. So what I need to do now is just switch this over to, right. So in order to start using Docker on your local machine, you're going to download something called Docker Community Edition. And currently the way it works is that if you want to run a Windows container, then you have to do a little bit of switching. So you have to switch over to Windows containers. And then when I've switched over to Windows containers, it will then give me an option to switch back to Linux containers, and I'll explain what the difference is. That's fine. Still switching over. So while that's switching over, we'll come back to that. So because of the way that networking works right now with Windows containers, I have to run a little command here to work out what the IP address is of the container. I have this little command here. This is all available on my GitHub, and I'll share the link to this so you can run through these steps yourself. I run that command after I run my container. This is the command, the Docker run command, to expose my container. I'm saying map the outside world port 999 to the port 80 on my container. So my container is running IIS inside of there, and I've mapped the 999 port into the IIS container 80. So let's see if I can run this container. Okay, that should be ready to go. It's just going to take a little while to run that. And as it's doing that, I will quickly show you the other Docker file that I was talking about. So the other Docker file was this console application, and that console application just simply prints out the Fibonacci series, and so it goes through, I think the default is 15, I think, yeah, the first 15 numbers of the Fibonacci series. So what we will do is, as we're waiting for that to come up, and you're going to see a little bit of a common theme here because of the way that, unfortunately, where some of the Windows containers kind of work only on a Windows 10 machine. So this experience is slightly different and a lot quicker on a Windows Server box. But because I'm doing all this development on the local machine, I really want to kind of show you some of the things that you'll be going through when you're actually developing containers on your local Windows 10 machine. So I've already built these containers beforehand, and I'm going to just do a Docker run on that one. So what I should see there is, for this, for the console application, is that it's going to run the exe, and the exe prints out to the console the first 15 numbers of the Fibonacci series. Whilst that's happening in the background, and I'm sorry I'm moving between the two things because it's just, I know it's a bit frustrating watching a speaker and then all you're watching is a command line and waiting for things to happen. But my first one has come back to me now. Oh, there we are. So it's printing a Fibonacci series. So in this Docker run command, I've not said I need to know about this exe, I need to know what it's called, I need to know what arguments to pass in. All I've done is said Docker run this container. And because my Docker file described what to do when the application began, it knew how to handle the starting of that. So if I go back to my first one, so I am now inside of my container here. Now normally you wouldn't do this, you don't normally interact with a container like this, but this is just for the purposes of a demo. So I'm actually terminaled into my container. I can't RDP into it because that's not permitted. They've not enabled that. So if I have a look at, for example, the host name, so Docker, in its very clever way, gave the machine its own host name. I can have a look, and it looks like it's running a full set of services as any other Windows Server machine would do. It actually looks just like a Windows machine. If I have a look at the list of files, there we go. We can see a list of files. However, this Docker's using a little bit of clever magic in presenting to the container that you have access to a full, services. You have access to a file system, memory, and all of that. That's all part of the goodness that something like Docker will give you, or whatever container technology you're using. You'll notice here that's the app folder that I copied into this directory, and there should be my website inside of there. And so now if I head over to, I've already got it here. If I head over to this URL, it's just displaying me the standard MVC template out of it. So it's not very exciting there, but you can get an idea of that a container kind of works in the same way that containers on Linux also work. Just as a, just to kind of give you one of the thoughts that come into mind is when you're running these things is you're thinking, well, hang on, what about my configuration? Well, one of the protocols in terms of passing configuration into a container, well, in the .NET world, we use our web config file. So our web config file contains app settings and various other bits and pieces, connection strings. Well, there's a protocol of passing these things in through environment variables. And when the container runs, then in this example here, I'm passing it in via the command prompt, but whatever orchestration tool that you're using will have ways of being able to configure these variables for the different environments. So here I'm now saying, actually, instead of printing my code says if there's an environment variable called Fibonacci_n, then use the number that it supplies as the number of iterations that you should print. So now you should only see 5 iterations of that. And so that's how we then begin to start passing in config. That's a real big thing for us in the .NET world, because a lot of the times we depend on the web config file for everything to be there. So let's head back to our presentation. So let's talk about a little bit about how this works under the hood. So Windows Server 2016 is the server host that enables a lot of this to happen. So Windows Server team really went to town on the product, and they had a look into the kernel, right down from the kernel of the operating system all the way up to enable this technology. So there is something called Windows Server Core. If anybody here who's on the infrastructure side of things, you've got Windows Server like the full GUI version and the core version. The core version doesn't have the GUI interface, so you don't get the IIS manager. You only get a terminal to manage the server. So that's more kind of like the Unixy, Linux type of way of doing things in terms of managing servers. But there's a new flavor of Windows Server called Windows Server Nano. And this one is really, really interesting, because Windows Server Nano, the team went and had a look at all of the code that was in the Windows Server base, in Windows Server source code, and had a look at all of the things that were necessary to run things like IIS, or run as a web server, run as a file server, DNS server, and then strip out all of the rest. And when they did that, and they had a look, they came up with this Windows Server Nano, a much smaller server. Now, if you've managed any installs of Windows Server, you'll know that the install is roughly, I think if you just download the ISO, it's around about 8 gigs, maybe 9 gigs, something like that. Windows Server Nano is, I think, somewhere, it's definitely lower than a gig. It was around 400 megabytes. I think it might be a little bit more now, about 600, 800 megabytes. But that is a massive, a really big difference, to go from 8 gigs to a server now only boasting, 400 to 800 megabytes. That's very different to something like the Linux world where, I don't know, Alpine, is it like 15, 16 megs or something like that? There's still a lot further to go. But when they stripped out all of that code and they had a look at all of the security bulletins over the last so many years, they realized that Windows Server will now require, or Windows Server Nano will require fewer reboots. You can see 80%, 92% fewer critical bulletins. They had a look at all of the critical bulletins they had to issue. So they've really, really improved the product drastically. But there comes some restrictions with that. And on Windows Server Nano, unfortunately, you won't be able to run your .NET full framework code. You'll only be able to run .NET Core code. So that was a little bit disappointing because it means that we can't use this really super duper server to run our full framework code. It's only in the new world, the .NET Core implementations. And it really is because they're moving to the, they're optimizing all of their products and everything for the cloud. So let's recap, remind ourselves where we are. So we've got a physical machine. The physical machine has a virtual host on there. The virtual host is running our containers. Okay. Now, Windows being Windows, there's something a little bit different. So we have this concept of what's called a Hyper-V container. So we have two types of containers in the Windows world now. We have what we call Windows Server containers and then Hyper-V containers. And Hyper-V containers are essentially a virtualization of essentially a virtual machine, but using the Docker tooling to manage that virtual machine. But it's a really tiny, tiny, tiny virtual machine. So I've been going a little bit slow, and I've still got quite a few slides. So what I'm going to do is I'm going to try and go through all of the important bits that I can do and try and cover this content. So when do we use both? The key thing is the code that you normally write in-house, you will use Windows Server containers. Code that you might want to host from somebody else, you would want to use Hyper-V container. Hyper-V container uses some hardware isolation, whereas a Windows Server container is all software isolation. And so there's stronger boundaries around the Hyper-V container, and means like in the shared hosting scenario, people will be looking at using the Hyper-V container. It does mean the Hyper-V container is a little bit slower because it's essentially a virtual machine, but you can still use all of the Docker tooling. And any containers you run natively on Windows 10 now will all run as Hyper-V containers, just so that it's got that extra security, which means it's a little bit slower. So when I did the Docker run, that's why you see a slight delay before the container actually runs. So Windows Server Nano is all about .NET Core. Okay, and what is .NET Core? Very, very brief mention of .NET Core. .NET Core is this cross-platform rewrite of .NET, which runs on Linux, Unix, runs on Mac. I'm not sure if it runs on Unix, but I think it does. Really optimized for use in the cloud, and it's this kind of it's the .NET framework, but broken down into smaller modules. They've really, really redesigned the whole thing. It's been in the pipeline for about 3 or 4 years. It used to be called Project K, was given all sorts of names, and now settled on .NET Core. And really, the .NET Core is what Windows Server Nano will be used for. Now, what I'll do is I'll just run through the rest of my slides and I'll very quickly show this the last demo at the end. So very quickly, compose it. Right. So now we have the ability to package our applications into a container and then run them within our container orchestration environments. Typically, our applications look like this, our monolithic applications. On one server, we have all of these applications. So now what can we do with containers? We split each of those different components into different containers. So we have our web application, we might have our API running in another container. We'll put SQL can now run in a container both on both on Windows and Linux now. And something like maybe Elasticsearch if you're using some sort of caching in there. now that it's containerized and we can run in a container orchestration environment, well, if your load increases, so what do we do now? We just bump up the number of instances of containers. So we just, maybe the front end is creating too much demand on the back end, we'll just increase the number of containers that are running. And the same for the front end. Maybe we get a little bit of load in the front end, so we'll increase the number of containers there. We can run all of this in Azure, and Azure helps to orchestrate some of the containers. Now, all of those commands that I was typing in, really you don't really get involved too much in that. A little bit of that, you need to know them, but products like Kubernetes, DCS, or, DCOS, Swarm, Docker Swarm, these are all now supported within Azure, so you can just package up your container, hand it over to Azure, and it will then, through an interface, help you manage the running of these things. So things like availability, recovery, and so on and so forth. The only demo on that one is actually just this command, because this command here, really powerful command, will set me up a Kubernetes cluster. Couple of projects I want to highlight. You might want to now think, okay, how do I go about now taking my existing infrastructure and turning it into containers? Well, there's this open source project called Image to Docker. You can run this against your existing IIS server, and it will go and investigate all of the IIS websites, turn them into a Docker file, and ready for you to go and run. Might be a little bit of additional config you might need to make in that Docker file, but it really does help. And really that's all, they're all the commands that you need to run for that. There's an example out there now, there's an application called Nerd Dinner, and Nerd Dinner was an application that was written for, I think, MVC3, and now that's been Dockerized, as it were. So you can have a look at this this Docker file, which describes how a really old MVC application can now run inside of a container. And this is work done by another Docker captain, Elton Stoneman, and it's really worth having a look at. He's written a blog post series about the things that he's learned along the way. So there's no excuse now for to be able to run your legacy .NET applications. So I've run out of time, but there are a bunch of resources out there. There's lots of videos. There's a really good ebook as well about how to do all of this in the Microsoft world. I will make this slide available and update the demos. There is some older demos of the Windows containers on that link at the bottom, but later on tonight I'll update that. So if you've got any questions, I'm around for the rest of the day. Feel free to grab me, and we can geek out about this. Okay, thank you very much.